Hello students, welcome back to Sanjay Agarwal maths classes. So this is episode number 4. We are doing 12th maths. The chapter is vectors. We have already done 3 lectures. Approximately each lecture is of 30 minutes. So today this is the episode number 4 and we will carry forward from where we left in episode number 3. Those who are joining for the first time today are advised sincerely to watch the previous 3 episodes so that there is a continuity and you are able to understand what I am going to teach you now. For your reference, let me briefly recap what we did in the previous 3 episodes, which I call them as introduction vectors. So, episode number 4, 12th maths on vectors. Vectors versus scalar. We understood what is a vector, what is a scalar quantity. Vectors have magnitude and direction. Then we did geometrical representation of vectors, free and localized vectors, parallel vectors, null vectors, unit vectors, what is vector I cap, j cap, k cap. So this was done in previous episodes. Negative of a vector, position vector of a point, and to express vector AB as position vector of B minus position vector of A. Addition of 2 vectors using triangle law of addition and parallelogram law of addition. Multiplying a vector by a scalar. How to prove 2 vectors parallel? I made a rule, I named it as ASC golden rule. Then section formula and centroid of a triangle is what is left in the introduction portion. So now I'll start this lecture with centroid of a triangle. So what you see on the blackboard is the synopsis of what we have done in previous 3 episodes. So this episode number 4 is going to be much more interesting episode as we are now going to start after I finish centroid of a triangle more on vectors, that is algebraic representation of vectors, and that is the portion with the help of what you are going to do your numericals. What we did in the previous 3 episodes was more of introduction to vectors, the theory of the vectors. So I'll rub off the screen. This is what we did in the previous 3 episodes. So now we start episode number 4 and the first topic is centroid of a triangle. You know what is the median of a triangle? Median of a triangle is a line segment joining the vertex of a triangle with the midpoint of the opposite side. So the topic is centroid of a triangle. So I have a triangle, say ABC. I have a triangle ABC. The position vector of point A. So if you have watched the previous episodes, you will be able to answer very quickly. Position vector of point A is vector OA. This is a vector joining the origin with this point A with the direction pointing from O towards A. And we write the position vector of a point in a bracket alongside the point. Position vector of B will be OB. Position vector of C will be OC. Let me find the position vector of the midpoint of BC. So that also we did in the topic called section formula. So position vector of point D will be called as OD, and you know what will be OD? It will be the average of the position vectors of the corners. So what will be position vector of D? Position vector of B plus position vector of C divided by 2. So this has been done in previous lecture. Now you join vertex A with D. So this is called the median of the triangle, and we have 3 medians from B. If I join the midpoint of AC, this is second median. From C, if I join this midpoint of AB, this is the third median. All the 3 medians are concurrent. What do you mean by concurrent? They pass through the same point of intersection, and this point of intersection is called the centroid of the triangle. So what is the centroid of the triangle? It's a point of intersection of the 3 medians of a triangle. Now what will be the position vector of point G? If I call it as G, then it will be OG, vector OG, and each median is divided in the ratio of 2:1 by the centroid. So GA is to GD will be 2:1. We don't have to prove it. So, this is just for your information. GA divided by GD will be 2:1. And what is the formula I am going to give you? What is the position vector of the centroid? So, the position vector of the centroid I can say like this, average of the corners. So, position vector of A plus position vector of B plus position vector of C divided by 3. Loosely speaking, I may refer the centroid as the midpoint of the triangle. There is nothing called midpoint of the triangle, just to bring a similarity between the midpoint of a line, which is the average of the corners. Midpoint of the triangle is also the average of the corners. Since there are 3 corners, I am going to divide by 3. So, that is the centroid of a triangle. There may be a 1 or 2 numericals I will do on the centroid of the triangle. So, that finishes the introductory portion of the vectors, and now we start something far more interesting, because that is where we are going to fetch marks. So, I will rub this off and we will now start the interesting portion of the vectors, which is much more easy to understand. Let me call that topic as more on vectors, or let me call it as algebraic representation all right. Now, as we have already done, x, y and z, these are 3 axes mutually perpendicular. A unit vector along x axis is given a symbol I cap. This we have already done. A unit vector along y axis is given a symbol j cap, and a unit vector along z axis is given a symbol k cap. So, this goes your first diagram in more on vectors. All right. Now, what is a position vector of a point? Okay. Let me take a 2-dimensional diagram, and that can be eventually used for 3-dimensional also. All right. Suppose I have a point here P, and the coordinates of the point is 2, 3. Okay, I am making a 2-dimensional diagram. First say x and y axis only. I am not introducing z axis in this diagram for the sake of making it simpler. This is the origin. Now, every point has a position vector. You know what is the position vector of point P? Vector OP. From O you take a scale, join it with P with a straight line, put an arrow like this. So, this now becomes a vector. Every vector has a definite magnitude, a positive number and a definite direction. Now, how do I express this vector? In terms of unit vectors along x axis, y axis and z axis. In algebraic representation of vector, every vector henceforth starting from now will be expressed as a linear combination of I, j and k. Means I am going to multiply I by some scalar number, multiply y by some scalar number, multiply z, k by some scalar number and add them. So, every vector will be expressed in terms of I, j and k. Let us start with this diagram. I have a point P whose coordinates are 2, 3. I join origin with P. This line segment with the arrow is called position vector of P. Now, how do I express it in terms of I and j? Suppose I drop a perpendicular here. Let me call this as A. So, the length of this line segment will be 2 and this will be 3. So, this is a simple concept of coordinate geometry. Now, if I make this as a vector O, right now I know the number, the length is 2 and the length is 3. If I make vector OA like this, I put an arrow of my own. Now, this has now become a vector. Till I do not draw an arrow, this is not a vector, it is just a line segment. Now, it has become a vector. What is the magnitude of this vector? You can very well see the magnitude is 2. What is the direction of this vector? It is along x axis, that is I cap. So, vector OA can be written as 2 I cap. In the last episode, episode number 3, we discussed scalar multiple of a vector. Now, I cap is a vector of magnitude 1 along x axis pointing in the direction in which the x coordinate is increasing. When you multiply 2 with I, this is called multiplying a vector by a number, and you do not put any dot or cross between the two. So, this is a vector. Every vector has a magnitude and direction. So this also was done in the previous class. What is the magnitude of this vector? 2 times the magnitude of vector I, which is 1. So 2 into 1 is 2. So this is the vector whose magnitude is 2. So you can see in the diagram the magnitude is 2. And what is the direction of this vector? The direction of this vector will be same as that of I cap, because the number we have multiplied is a positive number. If scalar is positive, direction is retained. If the scalar is negative, direction is opposite to what is that of I cap. So what is the direction of vector OA? Same along x axis in the increasing direction of x. And what is the direction of 2I? Again along x axis in the increasing direction of x. So vector OA now is vector 2I. Now let's make vector of AP. Right now it's not a vector. The moment I put a line, it becomes AP. So what will be vector AP? You know what is the magnitude of AP? 3. You can see it in the diagram. And what is the direction? Parallel to y-axis. I say parallel to y-axis. I say along y-axis, that is physically overlapping y-axis. That doesn't make a difference. Vectors are free to be moved in the space. This is the vector AP. You can draw it here also, if you don't change the direction and the magnitude. So what is the direction for this? J cap. A unit vector along y-axis pointing upwards is j cap. So I put j cap. So vector AP is 3j cap. What is 3j cap? I am multiplying a unit vector j by a scalar number 3. What is the magnitude of this vector? 3 times the magnitude of j cap, which is 1. So 3 into 1 is 3. So the magnitude of this vector is 3 and the direction is same as that of j. What is the direction of j? Parallel or along y-axis, that is upwards, pointing in the direction in which the y coordinate is increasing. Now you also read triangle law of addition. So what is triangle law of addition? If you add OA with AP, what will you get? OP. So this also was done in the previous class. Okay, you go from O to A, then you go from A to P and you rest here. The shortest distance between the starting point till the finishing point along with the arrow is called the sum or the resultant of two vectors. So what is vector OP? So vector OP is 2I plus 3j. So you see, you are expressing a position vector of a point in terms of I and j. I am again repeating, every vector henceforth from this point onwards will be represented in terms of I cap, j cap and k cap, and of course you should be clear what is I cap, j cap and k cap. I cap is a unit vector along x axis, j cap is a unit vector along y axis, and k cap is a unit vector along z axis. So let's create a formula for you. So I am going to rub off the introduction portion from the top. So I have some more space. Now I give you the first formula. Alright. Suppose you have a point whose coordinates are x, y and z. Instead of taking 2, 3, I am now making a 3-dimensional vector. So let me give this point a number. Let P be having coordinates x, y, z. Now what will be the position vector of P? So position vector I am writing as P dot P. Position vector of P shall be, in symbols it will be what? Vector OP. And now how do I express vector OP in terms of the coordinates and in terms of I, j and k? So if the coordinates were 2, 3, the vector was 2i plus 3j. So if the coordinates are x, y, the vector will be xi plus yj, and since now it's a 3-dimensional vector, so it will be z. So now you come across the very first formula which we will be doing in all the numericals. So if you know the coordinates of the point, you very well know its position vector. So simple it is. So I'll rub off this portion of the diagram also. If you are making a note of it and you are finding the time is not sufficient to copy it down, since I am progressing further into the chapter, you can pause your video and make a note of it. And I told you in the last class, please do make a theory copy, write down whatever I am teaching neatly and sequentially in your theory copy. Don't solve your numericals in that copy. For that you make a separate exercise book. Now, so the very first formula. So if you know the coordinates of any point, within seconds you can construct the position vector of this point. So let me take an example. Suppose you have a point A whose coordinates are 2, 3 and minus 1. So what will be position vector of A, OA, and what will be that? 2i plus 3j minus k, because it's minus 1. So 1 you don't write here, you want to write, you can write down. So it is so simple. How much time does it take? Maybe 2 or 3 seconds. Another example, you have a point B, say minus 1 by 2, comma 3, comma 5. This is the x coordinate, y coordinate and z coordinate. So what will be the position vector of point B expressed as OB? Will be minus half I cap plus 3j cap plus 5k cap. You know what is this vector? This is a vector whose magnitude is 1 by 2 into magnitude of 1, that is half. Direction is along x axis but pointing in the direction in which the x coordinate is decreasing. So you know the coordinates of the point, you know the position vector of the points. When I am doing numericals, see it is a line segment, this is A. Okay, the coordinates are 2, 3, 5. 2, 3, 5. So I can write its position vector as 2i plus 3j plus 5k. As you already know, I am repeating it. Position vector of every point is written in bracket just below the point. We physically don't show x-axis, y-axis, we physically do not show origin, and we don't join origin with A and put an arrow. That's going to make my diagram very cluttered. So we just write the coordinates and the position vector. Now if the coordinates are given, you know the position vector, it works vice versa also. Suppose there is a point B and you know its position vector as minus I cap plus j cap plus 3k cap. So I have not given you the coordinates of point B, I just gave you vector OB, that is position vector of B minus I cap plus 2j cap plus 3k cap. So you know what are the coordinates of this point? Minus 1, 2 and 3. So it is so quick to infer from one the other information. You are given the coordinates, you know the position vector of the point, you are given the position vector of the point, you can immediately find the coordinates of that point. Now I will rub these examples. Now when every vector has magnitude and direction, the opening line of episode 1, every vectors are physical quantities which require a magnitude which is a positive number and a direction to describe them completely, whereas scalars don't require a direction. So this is a vector expressed in terms of ijk. Why only this? Every vector will be expressed in terms of ijk. Now this is a vector. In this vector, two informations are very cleverly hidden: the magnitude of the vector as well as the direction of the vector. Now the question is, how do I extract these two informations from this vector, or say from this vector, or say from this vector? How do I find the magnitude of this vector and how do I find the direction of this vector? Finding the magnitude of the vector is slightly easier as compared to finding the direction. So today's class we won't be touching how to find the direction of a vector expressed in terms of ijk. Today we are going to find the magnitude of the vector which is expressed in terms of ijk. You know the symbol of magnitude of vector OP. You draw two vertical lines like this. It is also called modulus when used in numbers. Here it will be called the magnitude of the vector. So the formula of magnitude of the vector is square root of sum of squares of coefficients of I, j and k. So again we can make a poem here. What is the magnitude of the vector expressed in terms of I, j, k? It is the square root of the sum of the squares of the coefficients of i's, j's and k's. It is the square root of the sum of the squares of the coefficients of i's, j's and k's. Simply put, it is the square root of x square plus y square plus z square. So you may remember it like this, you may remember it like a poem. It is the square root of the sum of the squares of the coefficients of i's, j's and k's. So now can you tell me what is the magnitude of vector OA? The magnitude of vector OA will be 2 square plus 3 square plus 5 square, and you can calculate it. 4 plus 9 plus 25. Alright. So, it is so simple. You are given the coordinates of the point, you take few seconds to write its position vector, you take further few seconds to find the magnitude of that vector. Now, what do you mean by x component of this vector? This term will be called x component. And what are component of a vector, that also I will tell you. First, let me write the formula for you, then I will tell you what do you mean by x component and y component. So, y component of this vector will be y j cap and z component of the above vector will be j cap. At least even if you do not understand what you mean by x component, y component and z component, you can use the formula and finish your answer and get your marks. So, what will be the x component of vector OA? So, this is vector OA. So, its x component will be 2I cap. Alright, let me write down of OB, okay, vector OB. What will be x component of vector OB? Minus I cap. Y component 2j cap, z component 3k cap. Component of a vector is also a vector, so I will take up that topic once I finish writing this. What will be the x component of this vector? 2I cap, y component plus 3j cap, z component plus 5k cap. When it is plus, you need not speak plus, but when it is minus, you have to speak minus also. So, now again you know the coordinates of the point. You can write its position vector. You know the vector is in terms of ijk. In fact, every vector will be written in terms of ijk. Immediately within seconds you can write the magnitude of that vector. It is the square root of the sum of the squares of the coefficients of i's, j's and k's. Every vector will be expressed in terms of ijk. You can give the x component and the y component and the z component within seconds. You do not have to do any calculations. You have to just see and speak. That is it. So simple it is. But what is x component and what is y component and what is z component, I will take that up in another 5 minutes. Now, I am going to the next topic. So, this is what is interesting for vectors. So, what we did in the previous 3 episodes was little boring because that was hardcore, your theoretical concept of the vectors. How do I represent vectors on a plane by directed line segments, but now I will be just remembering formulas and doing my numericals within seconds or minutes. So, the first formula is in front of you on the blackboard. You know the coordinates of the point, you can make its position vector, you have a vector in terms of ijk, you can find its magnitude, you can find its x component, y component and z component. But how do you find the direction of a vector expressed in terms of ijk? That is a topic which we will be taking in the next episode. Now, let me now clean the blackboard and do the next topic. This is expressing any vector in terms of coordinates of its endpoints. All right. Let me do a 2-dimensional diagram and we will use it for 3D diagram also. You know why I am taking it for 2D, it will be little easy for you to understand. Suppose I am given vector A, not vector A, vector AB, starting from A and finishing at B, and I am given the coordinates of A and B. Now I want to construct vector AB in terms of I, J and K. Every vector, once again I repeat, will be expressed in terms of I, J, K. Suppose the coordinates of A are x1, y1. I am just writing a 2-dimensional vector where there is no z coordinate, and coordinates of B are x2, y2. Now, if I join I am deriving the formula, that is why I need the diagram. Once I explain the formula to you, going forward we will just directly use the formula. I could have given you the formula straight away, but I thought let me explain how do we derive that formula. Some of the students may be interested to know how exactly the formula has come up. The way I do a diagram, dropped a perpendicular on x axis and explain If the coordinates are 2, 3, vector OA is 2i plus 3j. Similarly, I am explaining now the derivation of expressing vector AB in terms of x1, y1, x2, y2 and with the help of I, j and k. I join these two. So now I am sure everybody can write what is vector OA, the position vector. So that you already know. If you know the coordinates, you know the position vector. x1 I cap plus y1 j cap. What is position vector of B? Vector OB, and that also you can now construct within seconds. x2 I cap plus y2 j cap. If you are still confused, pause your video, rewind it, go back and see the previous screen of the previous what I wrote on the blackboard just before this what I am writing now. So you will know. So if you know the coordinates of the point, you know the position vector. I told you vice versa also. If you know the position vector of a point, you know the coordinates also. Now let's use triangle law of addition here. So what will be vector OA plus vector AB? You go from O to A, you go from A to B, rest here. Now the shortest distance from the starting point towards the finishing point along with the direction, that is vector OB. This is what is triangle law of addition. So OA plus vector AB is equal to vector OB. Now rearrange. So what is vector AB? OB minus OA. Alright. So vector AB will be OB minus OA. Now let me write on this part of the blackboard. This part is still not used. So you may not see me completely in the frame when I am writing on this portion of the blackboard, but that's okay. You can see what I am writing and you can hear what I am speaking. So what is vector OB? x2 I cap plus y2 j cap minus OA. OB vector minus OA vector. What is OA vector? x1 I cap plus y1 j cap. Now you open the brackets and rearrange. x2 I cap minus x1 I cap plus y2 j cap minus y1 j cap. Now when these are two vectors in the same direction, one is pointing like this, one is pointing like this, what will be the total of this vector, sum of these vectors? x2 minus x1 I cap, and this will be y2 minus y1 j cap. So they can be clubbed together. Let me show you with a diagram from how I got this. Suppose this is 2i, alright, and this is minus 3i, and you add 2i minus 3i, okay, vector addition. So I told you in the previous class, when you add these two vectors, the magnitude will be 1, the difference of these two, and the direction will be in the direction in which the bigger magnitude vector is having. So what is this? You take I common, 2 minus 3, and you write I here, so it is minus I cap. You know what is minus I cap? A vector of magnitude 1 pointing in the direction along x axis, but in the decreasing direction of x. So the sum of 2i and minus 3i is also same. Okay, when you add these two vectors, the direction will be that of the vector having a larger magnitude, and the magnitude will be the difference of these two. Not minus is not the magnitude, minus only indicates the direction. Magnitude is 2, magnitude of 3, difference will be 1. So what you do is simply do your algebra. Like you know what is 2x plus 3x? Everybody knows you can take x common, 2 plus 3x, and then you can write it as 5x. You can obviously write it directly also. But right now I am creating a formula, so I do not know what is x2 minus x1. Here I know what is 2 plus 3, so I can directly write as 5x. But if I write ax plus bx, you will take x common and write in the bracket a plus b, because you can't know what is a plus b till you know the values of a and b. So this is so simple. So if you know the coordinates of x, a and b, you can construct vector ab. Again it is in terms of I and j. So every vector will be expressed in terms of I, j and k. I am repeating so many times this line. So now I can make a formula for you. So this was the derivation of the formula. Some of you may not be interested in knowing the derivation. You can directly remember the formula which I am going to write now and start doing your numericals, and you will get every numerical correct. So what I'll do is I clean the blackboard and write the formula for you now. So when I am writing the formula, I don't need to draw x-axis, y-axis and origin. Okay, I'll straight away do it in 3 dimensions. This is point A, its coordinates are x1, y1 and z1. This is point B, its coordinates are x2, y2 and z2. I put an arrow like this, so I need to make vector AB. First episode only we wrote, or maybe the second, every vector can be expressed in terms of position vectors of its endpoint. So what is vector AB? Position vector of B minus position vector of A, and when you apply the formula which I derived a little while ago, it will be x2, this will come first, AB, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So again it's so simple. So if you know the coordinates of any 2 points, that is the end points of your vector A and B, you can construct your vector AB again within say 5 to 6 seconds. So if you know the coordinates of one point P, you can construct its position vector. If you know the coordinates of 2 points, vector AB, starting point and finishing point, then again you can construct the vector AB. Now every vector expressed in terms of I, J and K has 2 informations cleverly hidden in the vector, its magnitude and direction. So what is the magnitude of vector AB? Magnitude of vector AB will be, you remember the poem I spoke, is the square root of the sum of the squares of the coefficients of i's, j's and k's. So it is x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. It is the square root of the sum of the squares of the coefficients of i's, j's and k's. Now what is the x component of vector AB? So this also I told you before this screen. X component is this along with I cap. So x component is x2 minus x1 I cap, y component is y2 minus y1 j cap, and z component is equal to z2 minus z1 k cap. So now you are in a position to express any vector given the endpoints of the vector. Let's take up a numerical. I still have to tell you how to extract the information about the direction of the vector and what exactly do you mean by x component, y component and z component. I am not going to skip that topic, but I am just postponing it. Let me give you the formulas, then I will explain what do you mean by x component and y component and z component. Alright, so let us take up an example. I have a vector A to B, that is vector AB. So I will write it as vector AB. The coordinates of this point are 1, 2, 3, minus 4, 1 and 7. Now I ask you to construct vector AB. So would you like to try? I will give you a few seconds. You go ahead and try writing vector AB. So what it will be? It will be x2 minus x1. So minus 4 minus 1 I cap, 1 minus 2 j cap, 7 minus 3 k cap. I guess my video may become longer than 30 minutes, but I will not stop in between. Let me complete this topic. So what will be vector AB? Minus 5 I cap minus j cap plus 4 k cap. I hope I have done my subtraction properly. Minus 4 minus 1 minus 5, 1 minus 2 minus 1, 7 minus 3 is 4. Now what will be the magnitude of vector AB? It will be square root of minus 5 square plus minus 1 square plus 4 square. That will be square root of 25 plus 1 plus 16. You can do your calculation yourself. Don't put plus minus outside. Magnitude of the vector is never negative. Even if you get root 25, I'll take up this topic some other day. Root 25 is 5. Root of 25 is not plus minus 5. This is a very common mistake lot of students will be making. Square root of a number is never negative. Square root of a number is always positive. Then why do we get plus minus? That topic I'll take some other day. Alright. So what is 25 plus 16? 5 plus 1 6. 6 plus 6 12. 2 3 4. So it will be square root of 42. I hope I did my calculation correctly. 25 plus 15 is 40. 1 and 1 2. 42. Okay. So this is the magnitude of the vector AB. And of course, you are in a position to write what is the x component of vector AB? Minus 5i cap. But what are they? I am going to explain. So y component will be minus j cap and z component will be 4k cap. So what do you mean by components will be taken up in the next episode. But before I conclude my episode number 4 on more on vectors, that's the real part of the vectors where you start enjoying vectors. I do agree episode number 1, 2 and 3 was very monotonous, but it was necessary for you to understand the physical and the geometrical meaning of vector. But for doing numericals, I just need the formulas which I am writing now on the blackboard. Now let us do addition and subtraction of two vectors. Now when I was adding vectors, when they were not expressed in terms of ijk, I required triangle of addition or parallelogram law of addition. But now I don't need anything. So I have vector A. Now I am representing vector by a single letter, a small case letter. It is x1 I cap. Let me start with the number 2i plus 3j minus 4k. And I have another vector B I minus j plus 5k. Now if I ask you what is A plus B. So I don't need any triangle of addition. I don't need any parallelogram law of addition. It comes naturally, very obviously. So I am sure everybody will say 2i plus I, 3i plus 3j minus j plus 2j and minus 4k plus 5k minus k. Oh my God, it was so simple, so quick when the vectors are expressed in terms of I, j and k, and when they were not. I needed so much of more information, so much of more knowledge. What is triangle law of addition? What is parallelogram law of addition? Here I don't need anything. I just do it as it hits me, as it just common sense. 2i plus I, 3i plus 3j minus j plus 2j. And what will be vector A minus vector B? I am sure all of you will write it also. 2i minus I cap plus 3j minus or minus j will become 4j and minus 4k minus 5k will be minus 9. So you will be so surprised, you will be so happy. Oh my God, it is so easy to add two vectors and equally easy to subtract two vectors. What were we doing in the previous 3 episodes? Why the things were made so complicated for us? But that is also a necessary part of understanding vectors. Alright, but the marks you are going to fetch from these formulas. Now again, multiplying a vector by a number. Number I means a scalar which could be positive or negative. So suppose I have vector, same vector 2i plus 3j minus 4k. For some reason you want to multiply vector A by 2. So you simply multiply both sides by 2. And now I don't have to tell you, you can tell me what is the answer of this. Open your brackets the way you usually open brackets. 4i plus 6j minus 8k. So this topic also got done so quickly. Addition of vectors, subtraction of vectors, multiplying a vector by a scalar, all these 3 topics was finished in 1 minute flat. No rules required, no triangle law of addition, no parallelogram law of addition. So that's the beauty. That's the beauty of expressing every vector in terms of I, j and k. So I'll end this episode for now, and then you can join back in episode number 5 where we'll carry forward from here, and I think one more episode number 5 will wrap up the theory of introductory part of the theory. What will be left after that will be multiplying two vectors. But before we start multiplying two vectors, once I finish the theory, I'll do at least 20-25 numericals with you so that you understand the theory better. Just listening and understanding theory will not make it perfect for you. You have to do some numericals. When you do more numericals, that theory becomes more clear to you and you know how to apply theory in practical situations while doing numerical. So, have a good day. It's over. This episode is over for now. We'll meet again in the next episode. Have a good day.